Hi, my name is John Maneatis from True Circuits. I'm here to talk about 20 years of timing excellence. So, True Circuits is a leading provider of high-speed mixed signal IP. We've got our headquarters in Los Altos, California, and we have sales reps worldwide. We have hundreds of customers, and we've been in billions of production chips. We're expert analog designers. We have leading edge R&D and a lot of in-house CAD capability that we use to automate our design generation, our testing, and everything. So the typical problem with choosing IP is trying to decide the right IP to solve the problem. There's lots of different possible application specs and things that have to be considered. There's the latest process nodes, all the process variants, metal stacks, VTs, and so forth that make finding IP potentially difficult. But True Circuits has you covered. We got full portfolio of PLL, DLL IP available. They're highly programmable, support different processes, applications, so forth. They're easily retargeted for different metal stacks, VT configurations, oxides, and because they're set up in such a general way, they very easily satisfy lots of different application requirements with the same IP. So we have hundreds of different part numbers. Check our website. Anyway, so for our timing IP, we have lots of different types of PLLs, clock generators, spread spectrum designs, and DSKU PLLs. We have our general purpose PLL, which is set up to be a very small form factor design. Our OTPLLs, which I'll talk more about next, which are set up for low area, low power, low cost for IoT applications. Our Ultra PLL, which is extremely flexible, extremely low jitter, set up for SerDes applications, ADC reference clocks, and other things. We also have delay lock loops, which are used for DDR, ONFI, and other type applications. And also a newer product that we have is our DDR Phis. And they are set up to be flexible, high performance. They support fully automatic training and make it very easy for customers to integrate. So all of our designs are set up to be very high performance and very general, easy to use. Our PLLs are low jitter, process tolerant, support large multiplication factors with small sizes, and very pin programmable. And that's important because it makes it easy for customers to use our designs for lots of different applications on the same chip. We can do customization. They're all fully documented and fully supported. So the OTPLL is a newer design we introduced. It can take a 32 kilohertz reference clock, which is a commonly cheap available frequency, and basically multiply that up to hundreds of megahertz for different clocking applications on wearable type chips. It's very wide range, supports multiplication factors of over 8,000, and once again, highly programmable and ideal for cost-sensitive applications. The Ultra PLL was designed to basically solve all one design that can solve basically every PLL application need. It uses a state-of-the-art architecture for producing ultra-low jitter, less than 1 femtosecond for the most demanding applications. It can multiply by over 250,000, so it can multiply up from like 10 kilohertz and produce 3.5 gigahertz output. It supports precise fractional N control with at least 26 fractional bits, and also can support spread spectrum clocks. Our DDR Phi is set up to make it very easy to include DDR on a chip. We have pulled in a lot of the difficult timing closure problems into the design so that we solve them ahead of time, and the customers simply include the IP and only have to deal with some relatively low frequency interfaces to the memory controller. All the training is fully automatic. It does read data I training, DQS training, VREF, and so forth. And it's set up to be very flexible. We can target any floor plan that you may have. We'll basically harden around your floor plan and give you a finished piece of GDS2 that you can then use to including your SoC. So I want to thank you for listening to my presentation. Please check out True Circuits at ChipEstimate.com. Use True Circuits on your next chip, and if you have questions, please ask. Thank you.